This is my project name, water level controller. Hi, my name is Kasmin Daniel, and currently I'm in semester 6, bachelor in mechanical engineering at UITM Shah Alam. My matrix number is 2019 678 826, and this is a project assignment for the class MEC 523 Microprocessor. And now I'm talking about the project background of my assignment. The project is based automatic water level indicator and controller. This system mainly to keep the water level in tank stable, to keep stop the DC motor when water spill out or water wastage, to avoid the tank running out of water, and also measure the water level by using mainly ultrasonic distance sensor, which play the most crucial part in this project. The ultrasonic distance sensor basic concept is using echo to hit obstacle and return to the origin as echo, but the traveling time for go and back is calculated and will define the depth or the level of the water. By applying this concept, we can determine the water level and combine with other devices. So this is the objective of my project or my system. The first objective is to produce a system that has two inputs and able to produce two outputs. The second objective is to achieve and maintain optimum energy procurement and utilizations throughout the system. The third objective is to minimize water costs and waste without disturbing the water supply and degrading the water quality. The fourth is to minimize environmental impact, and the fifth one is to apply engineering specialty in real world problem. And the last objective of my system is to sharpen students' knowledge and skill using Tinkercad and plus the coding. Now we continue with the problem statement. The first problem statement is in this project is to avoid water wastage. The second problem statement is to overcome problems such as forget to switch off the pump when the tank is full, or forget to switch on the pump when the tank is empty. And the last problem statement is to use affordable part to build the system and understandable. Okay, now we continue with the project methodology. When talk about project methodology, we'll discuss about the details and how the system functions. So the first one is project should have, in this project should have two inputs and two outputs, and the main components functions as crucial part is ultrasonic distance sensor, and there are four cases represent the level of water tank, which the first one is when water level is empty. Second is stable water level. The third is tank is full, and the fourth and the last situation or cases in this system is water wastage. And water level is empty means DC motor will be activated, buzzer beeping with tone 10. Yes, the buzzer will beeping with tone 10. And the second one is water level. What the water level stable mean is DC motor is activated and no beeping. And the third is water level is full. DC motor will be activated, buzzer will beeping with tone 20. And the last one is water level, water wastage, means the DC motor will be automatically stopped by the slide switch, which we code in the Tinkercad, and buzzer will be ping with tone 30 Hz. Okay, now we are continue with the components that we use in this system. The first one is the ultrasonic distance sensor, and the basic functions of the ultrasonic distance sensor is transmit the echo, and when hit the obstacle, when return at S echo to the origin, and the returning time or the go time will be calculated and will determine the level of the water. And the second components that we use in the system is H bridge. What is the functions of H bridge? H bridge will stop the pump or reverse the directions of the pump. And the third one is the buzzer. What is the functions of buzzer? The buzzer will produce sound or beeping with different tone. It can be 10 Hz, it can be 20 Hz or 30 Hz. And the fourth one is the DC motor. What is the functions of DC motor? DC motor in the system function as a pump. The DC motor will pump water. And the fifth components that we use is dip switch. Dip switch is same as the slide switch. The main purpose is same, which is to switch off or switch on the circuit, but have a slight differences. And the last components that we use is slide switch. As I said before, the slide switch function as switch off or switch on, but the slide switch is just contain a single button, and also can be coded in the Tinkercad. Okay, now we continue with the programming flowchart. As we all know that before we have the programming flowchart, we should have the text coding first. And the text coding is we make or we obtain from the Tinkercad. When we designing the system, we will have the text coding and convert to the programming flowcharts. So here is my programming flowchart, and the programming flowcharts containing several parts, which is the heading, the declare, and the void loop. Heading, void setup. Void setup means the system will activated once, but when entering the void loop, which means the core of the functions will activate the system several times. And here is my programming flowcharts, and in this programming flowchart I have 4 conditions. As I mentioned previous slide, the programming flowchart that I obtained from the text coding have 4 conditions or cases, which is when water wastage, water full, water is stable, and water empty. All have different situations and how the system works. So here is my circuit diagram. As we can see here, my circuit diagram contain the Arduino and also the breadboard, and the other devices that I use is buzzer, H bridge, slide switch, dip switch, and ultrasonic and DC motor. And this is the situations that represent the actual product. Okay, now we continue with the block diagram coding. As we can see here, that block diagram coding also represent the coding of the system. It's the same as the text coding, but this is presented in the form of a block diagram coding, but the functions is the same. As we can see here, there are different color of the components in the block diagram coding, and I want to explain each one of the color. The gray one, as we can see here, the comment and start there, means the gray is notations like start, whatever, but the notation will not affect the coding. And when we see the blue color mean output of the system. As we can see here, the print, the blue color is print to serial monitor, and there's a column there, level control system. This is considered as the output. And the purple color, I mean the dark purple, also mean input, and the orange color mean control the system, like if else, yes, that is the example. And the green color represent the math, for example, more than, less than, or equal to, and the list continues. And the last color is purple, but not the dark purple, means the variable means we set something. For example, we set trigger pin at 2, or we set the echo pin at 3, or we set the switch pin at 7. That is the example of variables. Thank you. Okay, now we are talking about the text coding, and as I say, at the previous slide, text coding is the same as block diagram, but this text coding is more to writing manual. And here we can divide the coding with three parts. The first one is the heading, the second is void setup or declaring, and the third one is void loop. And as we can see here is my void setup, and here I set the pin mode 7 is input, pin mode 2, 3 at 9, and 5 as the output. Okay, in this coding loop, in this area, void loop means the system will activate it several times based on what we coding. As we can see here, if this is represent the first case or the first situations is in my system, which is if the water level is more than 300, the switch pin or the slide switch will be activated. We can see here that digital read 7. This pin 7 represent the slide switch, and the output is serial print in, mean water was stage. We can see here that digital write 2 low, digital 3 low, and until the 9 is write low, mean all the pin is the output but switch off, and the tone will beep. We can see the tone here, play tone 30, mean the buzzer will be ping with 30 Hz. And at the second situations here, if water level in between 250 and less than 300, the serial print or the output will show that tank is full, and digital write at is high, means the DC motor is still activated. And we can see that here that the buzzer will be ping with tone 20. So here is the last part of the coding text, and we can see here that another two level. The level is between 40 to 250, less than 250. I code the output is a stable water level. Stable water level, we can see here the digital write 8 is high, mean the DC motor is still activated when the water level at this level. And if we can see here, if water level is less than 40, the serial print in or the output will show the tank is empty, and digital write with pin 8 is set as low, and digital write 9 is high, means the DC motor in this area is still activated. And we can see here the tone or the buzzer will beeping with tone 10 Hz. And that is the last case and last situations of my coding. Thank you. So now we already reached this result and discussions, and in these projects we were given by the lecturer a task to find and carry out a project, and in the project we must use the knowledge of microprocessor. We must apply the knowledge where the project must have 2 input and 2 output, and the project mainly will use the Tinkercad software and website as advised by the lecturer. And in my case, I choose the water level controller, and I use the devices such as a DC motor, slide switch, ultrasonic distance sensor, H-bridge motor driver, and buzzer as the main components. And the experiment mainly will be done and processed in Tinkercad software or website. And my project is a success because when I run the project, the simulations is running well as I coded in the Tinkercad. So for example, when the water level is more than 300, the DC motor in the system will be automatically stopped, and that is the proof that my system is success. Thus this system is a success, and by using the system we will able to maintain the water level at stable level and avoid water wastage. Thank you. So this is my experiment in short. I divide with the components involved and the situations involved. We can see the tank is full, stable water level, tank is empty, what is activated. We will discuss the first situations, which is the tank is full, buzzer will beeping, H-bridge activator, DC motor keep running, and the second one is stable water level. When the water level is at this level, buzzer no beeping, H-bridge not activated, DC motor will keep running. And the third is tank is empty. When tank is empty, buzzer beeping, H-bridge activated, and DC motor start pumping. Okay, now we continue with the experiments, another 2 situations, and what is the components that involves. As we can see here, the first situation or the second last situation is tank is full, tank is empty, tank is stable, or water waste. The situations can be these 4 at once, and the components involved is dip switch SPST times 4. By using this component, we can click the dip switch to stop the DC motor from running or pumping in 4 conditions, the situation there. And we can use the dip switch as emergency devices in case there is devices or parts in the system that misbehave. For example, when the DC motor is misbehave when it keeps running although the water level is reached the wastage level. And slide switch, nothing happens or not activated. And the last one is the situation in waterways. We can see here the dip switch is not activated, and the slide switch here is activated, will be automatically activated. I think that's all for the components and situation. Thank you. Okay, now this is my conclusions for my projects, and my conclusion is to successfully work with a control system, it is necessary to understand the concept and principle that typically used to explain the process control. In this project, I use a very simple system which utilizes a slide switch, dip switch, ultrasonic distance sensor which is connected to the buzzer, heads bridge motor driver which control the action of the DC motor either to stop or start pumping in both condition when water tank is full or empty. But despite the simplicity of the system, the number of principles, terms and concept involved is immense. Many of the principles and concepts were not addressed in this project, but those who are the basis for continuing a deeper study in the extremely wide world of control and instrumentations. I think that's all. Thank you, sir.